Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn. This is Suresh, Faculty of Chemistry. So, last 2 days for your dream NEET examination. How is the Josh? So, today I just want to make you to complete chemistry formula revision in one video. You can get 40 marks from this 1 hour session. So, it is, believe me, I am going to take you revision of all physical chemistry formulas. Pramila Devi, hi, good afternoon. So please confirm, can you all able to hear me and see me? So no big promotions in today's class. So let's go ahead with atomic structure and thermodynamics, equilibrium, chemical equilibrium, ionic equilibrium, chemical kinetics, and solutions and electrochemistry and everything. So whatever the formulas that are available, just in one shot I am going to take you and how to use it and how to point out these tricky things and everything. So no waste of time in today's class. Everybody just in the last movement of this last 2 days, never read anything new, but just revise the formulas, any graphs, any flow sheets, any diagrams are there. And it is going to be a celebration time. So it's countdown. Let's start. My dear children, here we are in structure of atom. In the structure of atom, right from beginning of Rutherford model, Bohr's model, quantum theory, and everything we'll just see. So the radius of the nucleus in the range of r is equal to r naught a to the power 1/3 centimeters. So a is going to be the atomic mass number of the atom. Okay, very good. Pramila Devi, come on. And also you can see the Planck's quantum theory, energy of the photon, light is a form of energy. It is propagated in the form of energy packets called quanta, and each quanta has a certain amount of energy that is equal to h nu and hc by lambda, and energy 1 by energy 2 is equal to lambda 2 by lambda 1. So it is one of the important ratios. Hi, Prashant Kaushik, good afternoon. And also you can see photoelectric effect, when a light allowed to fall on a clean metallic surface, ejection of electron takes place. So that photoelectric effect is explained by Einstein photoelectric effect equation here, that is E is equal to light incident light energy is equal to h nu is equal to h nu naught plus half mv square, that is equal to nu naught is equal to critical frequency or threshold frequency, and nu is equal to incident light frequency. So you can say E is equal to W naught plus KE, right? So you can say H nu is equal to H nu naught plus KE. So kinetic energy of the photoelectron is equal to H nu minus H nu naught. So kinetic energy is equal to H of nu minus nu naught. So in one session everything is going to be elaborately explained. So this is the equation where you can use it for physics as well as chemistry. So one shot, two birds. If critical frequency and energy of the incident light, if energy of the incident light is equal or greater than critical frequency or threshold frequency, then only photoelectric effect takes place. That's very, very important. So this is an amazing session. Mayan, yeah. So I wanted to say, please stay in the session and attend these formulas, total physical chemistry formulas in 1 hour. I am going to just show it for you. And in this Bohr's atomic model, electron revolve around the nucleus in a concentric circular path called orbits, and electron residing in a particular orbit, it has a certain definite amount of energy. That is given as quantization of angular momentum, mvr is equal to nh by 2 pi, and energy of the shell and energy of the electron is given as minus 13.6 by nz square upon n square, and the energy of the electron is always negative within the atom, and that expression is given as minus 2 pi square me to the power 4 by n square, and energy of the electron is inversely proportional to n square and directly proportional to z square. So as n value increases, energy value also increases, because this is a negative quantity. Mind it, this is a tricky point. Are you getting or not? Similarly, radius of the shell is given as 0.529 by n square into z. So if 0.529 into n square by z, and that is given as 2 pi square. So n square h square upon 4 pi square m e square z. And these expressions are given as a multiple choice questions in the upcoming NEET examination. There is a chance, and everybody focus on this kind of formulas. And velocity of the electron is 2 pi z square by nh. Wanted to say which of the following expression correctly matches with the velocity of the electron. This is very important here, and it is given as 2.18 into 10 raised 6 into z by n. As n value increases, velocity value decreases, you can say. Are you getting or not? Dear children, hope you are understanding. Mayan and Pramila, and stay tuned. I am going to revise everything here. And when an electron jumps from the lower shell to higher shell, energy is absorbed. When the electron jumps from the higher energy to lower energy is released. And the energy is absorbed or released is in the form of E2 minus E1 is equal to hc by lambda. That light is in the form of wavelength, and that wavelength can be calculated by Rydberg equation, and nu bar is equal to rz square of 1 by n1 square minus 1 by n2 square. Here Lyman series, Balmer series, Paschen series, bracket series and Fund series. In this case, n1 value is equal to 1, n1 value is equal to 2, n1 value is equal to 3, n1 value is equal to 4, n1 value is equal to 5. It is in the UV region, it is in the visible region, and these are all the infrared region. Lowest energy means highest wavelength. Energy is inversely proportional to 1 by lambda. So that if the energy is maximum, wavelength is going to the minimum. If the wavelength is minimum, you can say shortest wavelength, and that is called series limit. It's very, very important. Series limit, it's very important. So my dear students, please confirm you are all able to hear me. Perfect. You are all able to hear me. That's good. So let's see here. One more question. Number of photons emitted when the electron jumps from higher energy to lower energy state in the sample of hydrogen atom is given as maximum number of spectral lines n into n plus 1 by 2, or otherwise, so maximum spectral lines can be is equal to n2 minus n1, n2 minus n1 plus 1 by 2. So that is the maximum number of spectral lines. Based on this equation can be asked. And also de Broglie wavelength when an electron is revolving around the nucleus. Like any particle, so matter has a dual property. It has a wave nature as well as a particle nature, and this wave nature is inversely proportional to the momentum, and that is given as lambda is equal to h by p, okay, or h by mv. So lambda is equal to h by mv. You can say lambda 1 by lambda 2 is equal to mass 1 by velocity, mass 2 velocity 2 upon mass 1 velocity 1. And also, if a particle is moving with a kinetic energy, so lambda is equal to h by root 2 k e m. K is the kinetic energy, m is the mass of the particle. And also, if a particle is accelerated by applying potential, so that is equal to qvm, accelerating potential. Okay, that's very important. So wavelength of the electron is given as 12.23 upon root voltage, and if you are going to use this formula, you are going to get an angstrom units. This is a very, very, very important formula as far as this de Broglie is concerned. And also another is going to be quantum numbers. Quantum numbers, principal quantum number talks about to which shell an electron belongs. Its value is going to be 1, 2, 3, 4 till infinity. This is belongs to the shell. And azimuthal quantum number, orbital angular momentum of an electron, is given as nh by 2 pi. It is angular momentum, not orbital angular momentum. It's angular momentum, that is given as mvr. And azimuthal quantum number, it signifies to which subshell an electron belongs, and it is also called as orbital angular momentum quantum number. And orbital angular momentum is given as root over L into L plus 1 dot h by 2 pi. So this is very important, and this is different from this, is very important here. And also maximum number of electrons present in a particular shell is equal to 2 into 2L plus 1. Based on this, 2 times previous medical entrance examination question has been asked. And you can see orbital angular momentum iska value de diya mein. And also you have the spin quantum number, it can have plus 1 by 2 or minus 1 by 2, that's a different matter. Mock test के live class होगा, mock test का live आज शाम का होगा बेटा, प्रशांत कौशिक. Okay, so let us follow, and these are all the formulas. These are all the formulas we are revising here. Talking about stoichiometry, in that stoichiometry you can calculate the number of moles. If mass is given, number of moles is equal to weight upon molecular weight. If a number is given, number of moles can be calculated by number by Avogadro number, make it 6 into 10 raised 23, 6.022 into 10 raised 23, right? And if the volume is given, number of moles is equal to volume of the gas at STP and upon 22.4 liters. So these are the various formulas that can be interconverted by using this Y map. You can say it is a Y map. You want to calculate number of volume of the gas, number of moles into 22.4, right? And also weight of the substance is equal to number of moles into molecular weight. Like this you can have various mole conversions. Definitely you will be having a question based on calculation of moles. And talking about the concentration terms, sir, time thumbnail mein deta hu, so you just follow the thumbnail, my dear Prashant. Okay, talking about molarity, that is equal to molarity is equal to weight by molecular weight into 1000 by volume in milliliters. Okay, molality, it is the number of moles of solute present in 1 kg of solute, and that is going to number of moles of solute upon molecular mass into 1000 by weight of the solvent. And mole fraction, and mole fraction is the ratio of number of moles of a component to the total number of moles. And the sum of the mole fractions are always equal to 1 because it has no unit here. Mole fraction has no unit. And temperature dependent hai, temperature independent hai, temperature independent. Which of the following concentration term is dependent in temperature, independent in temperature? Like these questions can be asked. And percentage calculation, you can have weight percentage, weight volume percentage, and volume percentage. If the weight of the solution upon volume of the solution, it is weight volume percentage, and weight of the solute upon weight of the solution, weight percentage. Similarly, volume percentage. This is the strategy you need to have. Okay, and talking about a very good important thing, the molarity and the molality, how to calculate here, that is given by m is equal to molarity into 1000 upon 1000 density minus m into m2. And this formula can give you insight, shortcut trick for collecting information from molarity and calculating molality on vice versa, right? Hope you understand this. Talking about moving concept of equivalent weight, and redox is also incorporated here. And for the elements, equivalent weight is equal to atomic weight upon the valency factor, that is called Z factor. that can be calculated for different substances like acid and base and salt. That is given as, for an acid, molecular mass upon the basicity or the acidity for the acid or base. So for this a Z factor or N factor, for the number of H plus that can be donated by one molecule of an acid, for the bases, number of OH minus that can be donated can be taken into the consideration, my dear children. And also for oxidizing agent or reducing agent, so the N factor is going to be number of moles of electrons that is lost or gained, or otherwise change in oxidation state per one molecule of the reactant. Good afternoon, Abhinav. So our bond is almost exhal ho gaya abhi. So we are into the last stage of the NEET examination preparation. And again I am telling you, my dear children, tomorrow I want to revise all the organic reactions in one shot. And talking about equivalent weight is equal to atomic weight and molecular weight upon the valence factor, and talking about law of equivalence. So number of equivalents of a solute is equal to weight by equivalent weight. Equivalent weight means molecular weight by N factor, no? So that number of equivalents of a solute is equals number of moles of solute into valency factor, that is your N factor, bachcho. Are you getting or not? Clear? That's good. Now normality, if you take moles, molarity. If you take equivalents, that is normality. So the relation between the normality and molarity is equal to molarity into valency factor is equal to normality, right? You can mix the solutions and you can dilute the solutions, and everything you can use for the normality into molarity and molarity into normality. So for dilution, okay, at equivalent point, Sheikh Tahira, good afternoon. When one acid and a base is reacted, they are going to neutralize. Let us say it is an equivalent point. It could be oxidation reactions and redox reactions or acid-base reactions. At equivalent point, N1 V1 is equal to N2 V2. That's very important. Okay, that is the law of equivalence. And N1 M1 V1 is equal to N2 M2 V2. Okay, now talking about thermodynamics. So time we have to consume in such a way that in one shot, fat. Okay, thermodynamics, you have thermodynamic process. The process which takes place at constant temperature is called isothermal process. dt is equal to 0. And isotonic process, volume is constant, dV is equal to 0. And isobaric process, pressure is constant, dP is equal to 0. And also we have adiabatic process, you have change in the temperature is going to be 0. There is no heat exchange from the surroundings. That's the condition over here. And talking about IUPAC is sign conversion of the heat and work. Work done on the system, that is going to be positive. Work done by the system, that is going to be negative. We have to use this convention in chemistry. Physics mein ulta hota hai beta. Okay, so work done on. So this is the system and heat given out. So that is called Q is equal to negative. This is the system. Heat given in, that is going to be Q is equal to positive. Are you getting or not? Clear? If work done on the system, that is going to be negative, and work done by the system, work done on the system, positive, work done by the system, negative. That's very important. Okay? Clear? If you have any doubts, you can discuss with us. Good afternoon, Sheikh Tahira. First law of thermodynamics. If a system you consider, this is a system and its initial internal energy is U1 and you are given some heat, simultaneously some work is done on the system ताकि इसका state U2 बदल गया. So U2 आपको कैसे मिला? U2 is equal to पहले U1 था, इसके लिए Q दे दिया, WB किया. so that you can say this is going to be U2 minus U1 is equal to Q plus W, and U2 minus U1 is equal to delta U Q plus or minus W. That is going to be Q plus or minus W. This is what is called as first law of thermodynamics. If work is done on the system, W is equal to positive. Work done by the system, it is going to be work done is negative. Okay, today voice is perfectly clear. Thank you very much. Full volume. And calculation of heat, the total heat capacity Ct is given by Q by T and dQ by dt. The change joule per degree centigrade is the formula to calculate heat. And similarly, you have molar heat capacity, the amount of heat supplied to the system to increase the temperature 1 degree is called heat capacity. For 1 gram of substance is said to be specific heat capacity if 1 mole of substance is called molar heat capacity. And this is called molar heat capacity is of two types, Cp and Cv. Cv is molar heat capacity at constant volume. Cp is called molar heat capacity at constant pressure, right? And Cp is equal to gamma R upon gamma minus 1. Gamma is called Poisson ratio. Gamma is the ratio of Cp of Cv, and Cv is equal to R upon gamma minus 1, and Cp minus Cv is equal to R. So these are all the formulas, right? These are all the formulas in one shot, even from the thermodynamics. Maximum I can say day after tomorrow you are going to write your NEET examination. By this time you will be in the examination hall. Bacho, you feel it is the awesome experience before you going for the examination, attending the YouTube lesson, and you are following these sure short formulas, right? And talking about here specific heat capacity that I already mentioned, for 1 gram of the substance specific heat capacity, 1 mole of the substance molar heat capacity, right? And also work done. So isothermal reversible work done in the compression or expansion of an ideal gas, W is equal to minus nRT ln V2 upon V1. You can say it is a V2 upon V1. For reversible and irreversible isochoric process, volume is 0, change in the volume is 0, work done is also going to be 0. And reversible and irreversible isochoric process, dV is equal to 0, this is also 0. And reversible isobaric process, W is equal to minus P external delta V. This is very, very important. Okay. And also adiabatic reversible expansion, T2 V2 power gamma minus 1 is equal to T1 V1 power gamma minus 1. And gamma is a Poisson ratio, we know it. And also, and reversible work, and this is the formula. This up to here it is okay, you need not have to go in detail about this. And talking about constant volume process, you have to calculate Cv. Constant pressure process, you have to calculate Cp. Okay. Thank you very much, Prashant Kaushik. And you see here, constant pressure process, delta H is equal to delta U plus P delta V. You can say that is equal to delta H is equal to delta U plus delta nRT. Okay, so this is a very, very important. Delta N is equal to sum of the number of gaseous moles of the products minus sum of the number of moles of gaseous reactants. So I wanted to say here, the heat at constant pressure enthalpy, heat at a constant volume internal energy. The difference between these two, you just delta H minus delta U have to understand. Clear? That's very important. And if delta N is equal to 0, delta H is equal to delta U, delta N is greater than 0, delta H should be greater than delta U. If the delta N is less than 0, delta H is less than delta U. That's very important here. That's good. Now talking about second law of thermodynamics, Entropy of the universe continuously increases for an irreversible process, bachcho. So delta S universe is equal to delta S system plus surroundings should be greater than 0. It's always positive, bachcho. And is also entropy, and delta S system is equal to dq upon T. So as temperature increases, entropy increases or not? Of course, from the lowest condition it is going to be, the change in entropy is going to be the maximum. That is second law of thermodynamics. This is a very important tricky point. Entropy calculations, directly entropy calculation, you can use this formula and you can use this, and Gibbs free energy change. This is called Gibbs free energy change is nothing but the useful work done. Okay, so that is given by Gibbs Helmholtz equation, delta G is equal to delta H minus T delta S. If delta G is equal to 0, the system is said to be at equilibrium. If delta G is greater than 0, it is going to be non-spontaneous. Delta G is equal to less than 0, it is going to be spontaneous. So this is about delta G naught is equal to minus 2.303 R log K. Okay, and it is going to be at equilibrium, delta G is equal to 0 and delta G is equal to products minus reactants. So everything is indicated here. Okay, any doubt? Now thermochemistry. Thermochemistry is a part of chemistry where we study the heat changes during a chemical reaction. So for change in standard enthalpy, that is equal to delta H is equal to delta H2 minus delta H. So I want to say enthalpy of the reaction is equal to sum of the enthalpies of the products minus sum of the enthalpy of the reactants. If it is at standard conditions, it is called standard enthalpy change. Okay, if delta H is greater than 0 and it is delta H is a positive endothermic reaction, delta H is negative exothermic reaction. Okay, and it is said to be temperature dependence of the enthalpy of reaction is given as a Kirchhoff equation. Kirchhoff equation is going to be delta H2 is equal to delta H1 plus Cp T2 minus T1. Okay, and in this case Cp is equal to delta Cp is equal to products minus reactants. Okay, from this you can see enthalpy of reaction for enthalpy of formation. So the enthalpy change when 1 mole of a substance is formed from its constituent elemental substances is called enthalpy of formation or standard enthalpy of formation. Okay, from there you can calculate any thermochemical equation. Okay, enthalpy required to break the old bonds for the reaction minus enthalpy released when the new bonds are established. Okay, so the resonance energy delta H resonance is equal to experimental enthalpy of combustion minus calculated enthalpy of combustion or enthalpy of formation minus enthalpy of formation calculated. You can calculate, and the difference is going to be resonance energy. You can connect this concept from thermodynamics, chemical bonding, and organic chemistry as well. More the resonance energy, more is going to be the stability. And talking about the concepts in the chemical equilibrium, we know A plus B gives rise to C plus D, and rate of formation of rate with respect to A and B is given like this, rate with respect to the backward reaction is given like this. So at the state of equilibrium, rate of formation is equal to rate of disappearance, so that rate of forward reaction is equal to rate of backward reaction. So the ratio of the rate of forward reaction and rate of backward reaction is going to be a constant that is called equilibrium constant, that is given as a Kc. So equilibrium constant is constant and it is at molar concentration level, that is called Kc, and partial pressure level, that is called Kp, that is given as a Kp. So equilibrium constant in terms of partial pressure is called Kp. that is given like this. And how this Kc and Kp are related? Kp is equal to Kc RT to the power delta n. As you know what is delta n, bachcho? Delta n gas is equal to sum of the number of moles of gaseous products minus sum of the number of gaseous reactants. If delta n is equal to 0, if delta n is greater than 0, if delta n is less than 0, Kp is equal to Kc, Kp is greater than Kc, Kp is less than Kc. Are you getting or not? And based on this, you Kp दे सकते हैं, Kp कैलकुलेट करने का कोशिश कर, Kc देते हैं, Kp कैलकुलेट करने का पूछना है, and Kp Kc रेशियो भी पूछना है. So you can just take, जब R value is there na, you have to take this any R value, better you take Kc Kp 8.314 ले लो, joule Kelvin inverse mole inverse, and 0.0821 liter atmosphere mole inverse लेना. Okay, depending upon how the Kp and Kc values are been given. Now moving ahead, so any doubts? You please ask us. Is my voice is audible to you all, guys? Sheikh Tahira. Moving into equilibrium. Yes. So possible values of K, if K is equal to 1, K is less than 1, K is greater than 1. So if K is equal to 1, it is at equilibrium. If K is greater than 1, reaction ज़्यादा आगे बढ़ता है, so reactant कम होता है, product concentration ज़्यादा होता है, and vice versa. As K value increases, stability of products increases, and stability of reactant decreases, and time to reach the equilibrium decreases, and reaction जोर से चलता है. Effect of temperature, again you have Van't Hoff equation. So log K2 upon K1 is equal to delta H by 2.303 or 1 by T2 minus 1 by T1. So here at T1, K1 is the rate constant, and at T2, K2 is the rate constant. And the value of equilibrium constant is independent on the following factors. So NEET multiple choice question में सीधा ये form, E statements are important. Okay, प्रशांत, शायद Tahira, initial concentration में depend नहीं करता, presence of catalyst में भी नहीं करता, and the direction in which the equilibrium has been attained is also not dependent, and the presence of inert material is also not dependent. It depends on equilibrium concentration and temperature and stoichiometry. These are the various formats you need to know. And this K value, if K value is less than 10 power minus 3, equilibrium always favors in the backward direction. If K value is greater than 10 cube, it is going to be favored in the forward direction. If this equilibrium constant is in between 10 power minus 3 and 10 cube, equilibrium favors both forward as well as in backward direction. Okay, and concentration quotient, that is called reaction quotient. Okay, Kp हो सकता है, Kc हो सकता है. These are the Kc, Kp are studied at the state of equilibrium. It could be Qp or Qc. So that is the same version, but at any situation during the process, it may be at equilibrium or may not be at equilibrium. So whenever QC or QP values are given, you have to predict whether reaction आगे बढ़ता है और वापस आता है. That's very important. And I want to say, if QC is less and KC is greater, equation always आगे बढ़ता है. So it is going to be always favor in the forward direction. If QC is equal to KC magnitude, so reactant and the product, and it is exactly at equilibrium. If Kc come here, Qc ज़्यादा है, reaction always want to come in the backward direction. That is very important factor. And Le Chatelier principle, if a system is subjected to change in its equilibrium state is disturbed, it is going to re-establish its equilibrium. That is the nature of the equilibrium, that is explained by Le Chatelier principle by change in the concentration, change in the pressure and change in the temperature. And we know everybody follows this, and we have a trick, and you can use the trick, change in concentration, and that is all about if reactant concentration increases, reaction हमेशा आगे बढ़ता. Okay, if product concentration is increased, reaction backward favor. So if pressure is increased, if delta N is equal to 0, no effect. Okay, if pressure is increased, delta N is less than 0, if delta N is greater than 0. So the situation comes like this, you know, this is reaction favors in the forward direction, this is reaction favors in the backward direction. That is the trick. Okay, so temperature, delta H is equal to positive. Okay, so temperature is increased, reaction favors in the forward direction. If delta H is equal to negative, if temperature is increased, reaction favors in the backward direction. So these are the various factors that you can see. Okay, inert gas, very important, inert gas. If inert gas is introduced at a change in the volume is 0 at constant volume, and change in the pressure is equal to 0, here no effect, here no effect, here opposite effect, of pressure, increase in pressure. Opposite effect is increase in the pressure. Understand? Clear? That's very, very important. You are going to get a question from Le Chatelier principle, no doubt about that. Okay, quickly let us complete the ionic equilibrium. And ionic equilibrium, Oswald dilution law, and alpha is root Ka by C is the Oswald dilution law. As concentration increased, as degree of, as concentration is decreased and degree of dissociation is going to be increased. And common ion effect, the dissociation of weak electrolyte is suppressed by addition of any strong electrolyte to that if the common ion is present. And talking about ionic product of water, the product of H plus concentration of OH minus concentration is called ionic product of water. Deborah Roy, good afternoon. And its value is going to be 1.7 into 1.0 into 10 to the power of minus 14 mole square per liter square at 25 degrees centigrade. That is very, very important. So pKw is equal to minus log Kw, and Kw is equal to Ka Kb, and pKw is equal to pKa plus pKb at 25 degrees centigrade. These are true, and at 25 degrees centigrade I have given, right? As temperature increases, ionic product of constant increases. That's very important. Talking about pH scale, the power of hydronium ion concentration and negative logarithm of H plus ion concentration is called pH, and it is supposed to be greater than 7, it is basic, 7 neutral, less than 7 it is going to be acidic. Deborah Rai, last 2 days, okay, 48 hours left. So countdown starts. Enjoy. Don't increase pressure in the mind. Chill with us. We are doing our best and we are doing hard work to make you to stay motivated, right? And talking about pH of weak acid. So weak acid, yes, excited for the examination. Wonderful. That is given as simple pH is equal to minus log root Ka dot C. Ka is called acid dissociation constant. Similarly, weak base POH is equal to negative log to the base 10 root Kb dot C. And you can say for monobasic. So you can have buffer solution, a solution which resists the change in the pH is called a buffer, and it has a reserve acidity, reserve alkalinity, and you have acidic buffer. It is a mixture of a weak acid and its salt with a strong base. And basic buffer, it is a mixture of a weak base and its a salt of a strong acid. And also you have ampholytes. The compound contain acidic or basic groups and therefore exist as zwitterions like an amino acids, and the proteins or ampholytes can act as a buffer. Dear children, you can say a mixture of normal salt and acidic salt can be a buffer. So in the NEET examination, which of the following act as a buffer? You can calculate it, and you can have the buffers, and you have the calculation of the pH of a buffer. You have buffer capacity. Buffer capacity is the number of moles of the acid on the base that are required to add to change the pH by 1 unit is called buffer capacity. And to calculate the pH of the buffer, you have Henderson-Hasselbalch equation. That is for the acidic buffer, pH is equal to pKa plus log conjugate base means a salt beta. This is salt by an acid, and for POH, for the basic buffer, pKb plus log salt by base. Okay, so this is Henderson-Hasselbalch equation. Hope you understand. So let's talk about the salt hydrolysis. Salt hydrolysis is the reverse of the neutralization. Acid plus base gives rise to salt and heat, and salt react with water gives rise salt and water. So salt hydrolysis is endothermic process. You have various types of salts. Okay, so salt of a strong acid and a strong base is neutral and no hydrolysis takes place. Salt of a weak acid and a strong base, look at this, जहाँ पर strong होता है इसका nature ऐसे होता है, and strong acid and weak base, it is going to be acidic, and weak acid and weak base, this could be slightly acidic or slightly basic. And these are the various formulas to calculate the degree of hydrolysis, H, and hydrolysis constant KH, and these salt solutions has different pHs, and directly you can calculate the pH of the salt solution by using this. Among these three, I strongly believe you may have to get from this. You may have to get from this pKw plus pK minus pKb by 2, because it is there in the NCERT. My dear children, hope you understand. Clear? And solubility and solubility product, and the product of the ions that is at a saturated solution of a sparingly soluble salt is called a solubility product. It is called as KSP. And you can say for CaF2, KSP is equal to Ca2 plus F2 minus a square, and Ag to silver chromate, Ag to CrO4 gives rise to Ag plus and CrO4 2 minus, so that it is going to be Ag plus square CrO4 2 minus. Are you getting or not? And you can have for binary electrolyte, this is very important, solubility product, it is going to be given in this way, and the relation between the solubility and the solubility product is also be given. Okay, and the solubility product and the precipitation. If solubility product and ionic product both are same, you can say it is going to be at equilibrium saturated solution. If solubility product is more, ionic product is less, it is going to be unsaturated solution, precipitation do not takes place. If solubility product is less, ionic product is more, you can say it is going to be supersaturated solution and precipitation takes place. Are you getting or not clear, my dear children? And talking about the solutions, we have colligative properties and Raoult's law, you focus here. So I want to stick on to the solubility and Raoult's law. Yeah, Chandrahasini, good afternoon. I'm fine, thank you Betty, how are you? All the best for everybody. Mayan, Prashant Kaushik and Abhinav and Shaikh Tahira and Deborah Tarai, Chandrahasini, all the best for your NEET examination. So let me quickly say, so the vapor pressure of the solution is directly proportional to mole fraction of this component in the liquid. That is given as a Raoult law for a binary or ideal solution. Okay, that is a various jumbling formulas. Okay, you can have the mole fraction in the, yeah, in the vapor state as well. Okay, so colligative properties, those properties whose properties depends on exactly number of moles present in the solution but not the chemical nature. They are called colligative properties. Relative lowering of vapor pressure is equal to mole fraction. P naught minus Ps upon P naught is equal to mole fraction, and from there you can calculate the molecular mass also, and you have elevation of boiling point. Elevation of boiling point, delta Tb is directly proportional to molality. Delta Tb is equal to Kb into molality. Kb is called ebullioscopic constant. Molal elevation constant, definition is important. Thermodynamic formula is there in the NCERT, that is also important. Okay, you see how the flow is going on. Depression and freezing point, it is depression and freezing point is the same way when you add some non-volatile solute. So in order to say colligative property, you are dissolving some non-volatile solute in that, so the solute should be non-volatile. Understand? And here this is Kf is called molal depression constant. Okay, that is given thermodynamic equations. These thermodynamic equations are very important in the NEET examination. So at the end, when you complete your NEET examination, you ask us again, sir, you discussed the formulas that is there in the NEET examination. Understand? And also osmotic pressure, that is pi is equal to CRT, you can say pi is equal to CST or CRT. So that is given as an osmotic pressure, and you can say isoosmotic, hypertonic and isotonic, hypotonic. You know the biology students what exactly happen over here. And abnormal colligative properties is given as a Van't Hoff factor, and the Van't Hoff factor is the ratio between theoretical molecular mass upon experimental molecular mass, and observed colligative properties and upon theoretical colligative property. If I is equal to 1, no association or dissociation. I is equal less than 1, association takes place. I is greater than 1, dissociation takes place. Understand, dear children? Any doubts? That's good. And the relation between the I and degree of dissociation, I minus 1 by n minus 1, that is for dissociation, and I value I minus 1 by n minus 1, that is going to be association. Understand? Dissociation and association. So electrochemistry, quickly do it. For any electrode, you will be having an oxidation potential and a reduction potential. A potential is experienced when a metal is immersed in the electrolyte is called electrode potential. If it is at 1 atm at 1 molar concentration at 298 Kelvin, is called standard electrode potential. Electron lost oxidation, so standard oxidation potential. Electron gained is called reduction, that is called standard reduction potential. Okay, and this Nernst equation, definitely you just take this into the action, and EMF is equal to E naught minus 0.0591. You can take cleverly 0.06 upon N log Q. Q is equal to reaction quotient. At equilibrium, it is going to be at equilibrium constant, and delta G is going to be 0 at equilibrium constant. Gibbs free energy change is given as delta G is equal to minus NF E cell. N delta G value is additive, you can add. Okay, electrode potential values are not additive, you can't add them, mind it. And also you can say the equilibrium values is equal to E naught cell, you can directly use this, mine equal to 0.0591 by N value log equilibrium constant value. Okay, and also different types of electrodes, metal and metal electrodes are there. You can directly use Nernst equation like this. So metal ion equals equation you have to take, and gas ion electrode, you can say the pressure upon the concentration. So hydrogen electrode calculate करने के लिए pH से ये सीधा इस्तेमाल करो, it's very very important. Based on that, 2 times so far the questions has been asked, my dear children, right? Chandrahasini. And also electrolysis, when the electrolysis taken, if you use inert electrodes, you have to use discharge potential order, and this is the order of discharge potentials, and you can directly use and you can predict what type of product that can be formed. If it is at active electrode, anode dissolves and cathode deposits, that's not a big deal, right? And also Faraday's first law, the amount of substance that is deposited directly proportional to the quantity of charge passed through it, and W is directly proportional to Q. W is equal to ZQ, and you can say directly you can use W is equal to ZIT, it doesn't matter, and I is the current, and T is called time, and Z is called electrochemical equivalent. Okay, and Faraday's second law, that is W by E is constant, he wanted to say. So W1 by E1 is equal to W2 by E2. What is E? Equivalent weight. Okay, and current efficiency and conductance, and we are close to this. And conductance is inverse of the resistance, and a specific conductance that is equal to K into 1 by rho, that is called specific resistivity. And specific conductance is the conductance offered by 1 cm cube electrolyte, and equivalent conductance that is given as K into 1000 by normality. And you see units also, ohm inverse centimeter square, equivalent inverse, and molar conductance K up into 1000 by molarity. If you take the molarity and normality, this makes the difference. And also specific conductance is equal to conductance into L by A cell constant. And Kohlrausch law, when solution is infinitely dilute, ionization is completed, each ion migrates independently and contributes to the total molar conductivity, is called as Kohlrausch law. Let's see the application of Kohlrausch law. You can see calculation of the limiting molar conductance of electrolytes, like, and to calculate the degree of dissociation or association. Okay, that is lambda alpha is equal to limiting molar conductance at a given concentration at a 0 concentration. Once you get the alpha, you can calculate the Ka or Kb, C alpha square by 1 minus alpha. Okay, that is given as Oswald dilution. Are you getting or not? Solubility, product of the sparingly soluble solutions, solutes. So that is given as K into 1000 by solubility, that is molarity only. Okay, and in the chemical kinetics you have rate and velocities and all, you have integrated rate expression for the zero order is there. So integrated expression for the zero order, C naught by Ct upon T. Graphs are also very important. We are coming to the end, and for the half life it is given as T half is equal to C naught by 2K. Okay, and also for first order reaction, that is going to be 2T is equal to 2.303 by K log A by A minus X. okay, for half-life is equal to 0.693 by K. So of course you all know these formulas. But the thing is, let us see the average, okay, let us see the graphs are very important. For 3 graphs are there in NCERT. I have taken this. This is the zero order curve, concentration versus time, and it's going to be straight line with a slope is equal to minus K. Hi, Karim. And let's talk about first order ln r upon t. You are going to get a straight line with a slope is equal to minus K, and slope is same for these two, but on the y-axis you have to check it. That is a key point between this, right? And also one more important thing, log r0 by r upon t is going to be a straight line passes through the origin. Slope is equal to K by 2.303. That's very, very, very important. There are 3 graphs and 2 more graphs are there. There are 5 graphs from the chemical kinetics. From there you can get it. And effect of temperature, whereas temperature is increased, rate of reaction is increased. That is explained on the basis of the Arrhenius equation. And Arrhenius equation says this is also temperature quotient. Temperature quotient Tc is equal to K1 plus 10 by Kt, and the equation can be solved nearly 2 to 3 times. And activation energy, you know it, and K is equal to A E exponent A by RT, okay, EA by RT, and solve is a log K is equal to minus EA by 2.303 into 1 by T log A. So you are going to get a graph between, okay, log K and 1 by T is going to be a straight line with a negative slope. It is going to be EA by slope is going to be EA by 2.303, okay, and also that is going to be given, and slope will be given. You are asked to calculate the activation energy. My dear children, this is very, very important, okay, and in this 1 hour time we completed right from atomic structure, Rutherford model to complete formula still chemical kinetics. You see, there are 100 slides has been rolled in last 57 minutes. So this is the same thing. You just go through it and you will come to know बार बार ये formula देख के NEET examination में when you see the question, yes, in the YouTube channel Suresh sir is given this formula and you can calculate the same, you can apply the formula, you can directly calculate, and calculation based, physical chemistry formula based, and I don't think so big calculation things will come, and from the physical chemistry 40 marks is yours. So you are now grabbed 40 marks in this 1 hour session, and tomorrow I want to talk about all organic chemical conversions, and we'll play with organic chemical conversions, all name mode reactions for tomorrow. So hope you enjoyed today's class. Amazing, thank you, wonderful. Chandrahasini, Karim, Prashant, and Abhinav, Mayan, and Shaikh Tahira, and Debrata Roy, all the best, and God bless you for your next 48 hours. So after 48 hours you will be disconnected to us, and after examination we will meet with paper discussion. So you will come to know आप क्या सही किया, क्या गलत किया, है ना? So how is your Josh? Prashant, Karim, Chandrahasini, Debrata Roy, Sheikh Tahira, wonderful. So we did well, and we are going to do some more amazing things in tomorrow's session. So signing off, Suresh, Faculty of Chemistry from Infinity Land. Thank you. God bless you all. See you.